Yeah, also thank you to the organizers for inviting me for this. Actually, very happy to be here to meet you all. I think it's a very exciting group, a lot of different backgrounds, and I think it's just great opportunity to see how we can collaborate. And today I want to talk a bit about IPCC, and specifically about the visualization within IPCC. I will give a few examples of how this was approached in the whole IPCC process. I will give some very practical tips on visualization in general, so more of the theory behind design principles and what you can actually use in order to improve figures, and if you have better figures, you have a higher chance to get into a journal or to have a nicer report. So this can be useful. And then we'll I prepared a notebook that the first 5 minutes we'll just do together, but then it's really up to you to choose a figure from the IPCC report and recreate it using some software package, using just basic Python. And that shouldn't be very difficult because the package is already installed, so that's it should be easy. But that's only for later. So just a general introduction about myself. I am now assistant professor in Utrecht at university, and my main research is about cost-benefit analysis, really more the damages of climate change. But besides that, in the past 4 years, I kind of rolled into the process of the IPCC. It all started with Detlef, who will give a talk tomorrow, day after, just asking me to make a few figures, and that kind of went out of control. And then I end up with spending months of my time on these kind of things. It just started with a few figures for chapter 3, which is the chapter on IAM results and long-term strategies of the Working Group 3 report. Then I had the chance to be involved in the SPM of Working Group 3, which was very exciting. It was very great. It was just a great opportunity to see how this all works. And I was more involved in the creation of figures and the calculation of data together with a few other colleagues. And then recently there was the approval session of the synthesis report, and I was also involved in making a few figures and doing some calculations there. And I will share a few stories because I think it's a fascinating experience, and it's good to have a little bit of insight of how these things work. So anyway, about IPCC, it's actually a perfect continuation of the lecture by Celine, because in one of the most iconic graphs is the first graph from the synthesis report, from the SPM of the synthesis report, and Celine already showed the bottom part of it, and it is called, like the title here is called, Adverse Impacts from Human-Caused Climate Change Will Continue to Intensify. So that's already quite interesting that there's a message there. There's a title, we call it an intent, and every figure has an intent. I will come back to that often. I will stress to you that you always have to put an intent on your figure because that makes them very readable and it really shows what the message is. But if we zoom in on the bottom figure, what I really like about this figure, Celine already introduced it, but it is very visual. It really tells a story. It tells when you see it, when you read it, you can follow along. You can recognize yourself in. You can kind of see where you are. If you're born in, I was born in 1994, so then I know I'm somewhere in between here. That means that when I'm old, I will experience a certain level of climate change. I'm expecting a child in September, so I know that my child will be probably there. And it kind of really tells the story in a very visual way. You follow it, you see directly what the message is, even though the data underlying it is just very complex. It's a result of a lot of climate simulations. And this figure got picked up in the media a lot. There were many news stories which are just about this figure. And an example that I like is so Nicole Kellner. I don't know if you know her, if you follow her on Twitter. If you don't, please do. She's a graphic designer who just makes drawings with aquarelle, with watercoloring, and of all sustainability related topics. And she reproduced this figure, and she tells about the first of all, I think it's a very appealing way of representing the data. It just has this watercolor feeling, and it fits in a whole group of other figures that she made. But she thought about it. She has a whole blog post about it, and what she said, I'll just read it. So it was, first of all, it was very difficult to make the figure like from a data point of view for her, but then there was an emotional challenge. Like with the hundreds of tiny brush strokes, it created a uniquely tactile experience of feeling each of the warming scenarios. I think it's beautiful. I think it really shows that the emotion behind this this figure. That was just experienced by her, but I think many people really just felt that this really touches people. So, and that's the ultimate goal of a figure, is that you present your message in a clear way that kind of have people feeling it. All right, that's about this figure. I will now focus a bit more on working group 3. So the previous figure was in the synthesis report. This one is really more about working group 3. There were 8 figures in working group 3. And with the IEM community, we were mostly involved in figure SPM5. And this is figure SPM5. As you can see, it's like extremely complicated. It's a 2-page figure. It's the only figure that is a 2-page long. And from a technical perspective, I was the one making this figure, and it was made purely in Python, which I don't recommend. Don't do everything in Python. Just make your base figure in Python, make it pretty, and please use something like Illustrator or Photoshop or Inkscape if you want open source, and then start doing Nico agrees. Then start doing some more of the design aspects there. This was like thousands of lines of code, but yeah, I couldn't use Illustrator and I could use Python, so yeah, then you kind of end up with that. But it's a very complex figure. But again, if you focus on the left top, you again have this intent. You have the title. What is the main idea of this figure? It's modeled mitigation pathways that limit warming to 1.5 or 2 degrees, involve deep, rapid, and sustained emission reductions. And this deep, rapid, and sustained emission reduction was really one of the key messages as well of this working group 3 SPM. And okay, then you have an intent, but how do you actually show this message to policymakers? And so the way that you kind of directly see it here, that okay, you have in red, I don't show the legend, but if you see the legend, you see that in red is like the current policy, like an extrapolation of what is going on if we have current policies. And if you want to reach 1.5, the blue one, or 2 degrees, you just have to go down very steeply. It's a very visual way of showing that you have to go down and you have to stay down. That's but there are many more messages. So this is my main thing. Have a main message. You wanted an M. I will continue about this, but have a message. Every figure should have a message. And by the way, if you make a figure for scientific papers, they hardly ever have an intent like this. Hardly ever have a message, which I think is a pity. But just do it, and you can always remove it if it's and at least do it for yourself, that you know what the message is behind your figure. It should just be clear. But there's many more things here. For example, one of the other messages that we wanted to show is that very easily the year of net zero of CO2, which is this bar, is just before the year of net zero of the GHG emissions. So here you got on the left you see the GHG emissions. On the right, you see CO2. On the left, you see that the year of net zero GHG is just at the end of the century, if reached at all. For CO2, it's much earlier. And actually, it is also earlier for 1.5 than for 2 degrees. There's a lot of these messages here. And from a visual perspective, this is not a perfect example because it's way too complicated, but that's a result of all kinds of negotiations. But still, if you only want to present the data, then it would have been sufficient to have on the right have only this colored bar, and on the left have here the bar for the GHG. But just someone came up with the idea of having this comparison between the two by having it in gray behind it. And this is the kind of design elements that I want you to think about. What makes it easier to read? It's not strictly necessary for the comprehension of showing your data. But this is what makes a difference between like a data figure and a message figure. So you can have these secondary messages here. All right. So then let's go. Oh yeah, a little bit of a story of the politics behind these figures. So as you can see, there are 8 figures here. That's all the figures. I took this screenshot from the website of the IPCC, but this was the Google Drive at the beginning of the approval process with all the figures in there. And you can see that, hey, there's a figure SPM9. And that was, so we had 9 figures actually. Now, this 9th figure that we started with in the beginning of the approval session looked like this. It talks about the mitigation investments needed for a certain warming, for a certain climate category, and there's differentiated by sector and by region. It's a very interesting figure. It's very insightful because it just shows how much investments you need to do. And the authors of this figure spent a lot of time in creating this figure, making it nice. It did in collaboration with the designers. The data behind it was they thought so much about of making this figure. So there's a whole process behind it. Now, there's one problem: is you see this, you cannot even read it, but there's these little boxes here. So there's this differentiation between the regions Europe, North America, and Australia, etc., and the regions that are below here. And the difference there is these are following the UN definition of the developed countries. These are the developing regions. And at the end, during the whole approval session, there was a big discussion. Like, some countries wanted to have this box removed, and some countries wanted to have that box inside there. So there was really a big clash. It was actually, so the US wanted to have this removed, and China wanted to really have it kept in there, as the authors had prepared. And actually, it has nothing to do with the message of this figure. This figure is about investments. But the political battle that happened around this figure was purely from a UN perspective, that whether China is a developing country or not. So that's a whole UN discussion that has nothing to do with climate change, let alone with this figure. But because there was no consensus on that at the very last day, I think it was in the last half hour, if there's no consensus, if not everyone agrees on it, the figure has to be removed. So it's just gone. And it was very emotional. I mean, I know how much time I spent on my figure 5, and I was just super relieved when it got accepted. And here there were tears. It was very, very emotional. I mean, it's just the result of a political process that has nothing to do with this figure. By the way, this is not confidential. There's a report about it by the IISD, which is like a newspaper, and you can read about what's being said there. It's fascinating. So yeah, there's just the context of these, the political background of these figures that you just have to take into account. I mean, I think if the authors had just not bothered having this in the first place, it wouldn't have been a controversy. But yeah, that's how things go. All right. So and oh yeah, just to put some context. I don't know if you have seen this picture, but this is what it looks like. This was in the synthesis report in Switzerland. So all the delegations are in a big room, and then there's the authors are then somewhere over there. And when there's your figure or your text, it's mainly about text that is being talked about, then you're sitting on the podium. Here you see it's the same picture, but then from the other side of the room, you see the podium, people sitting there, and these are all the authors discussing together, like how can we address the issues or the points raised by the government? How can we try to find a compromise? How can we actually use those comments to improve the text? Hopefully, or sometimes you make it less readable, but that's just the process that you have to work in. And it's not always easy. It's actually very tedious and frustrating sometimes. Here's a picture which I find an amazing picture. This was at the last day of on Friday, and just look at every single people's face. Everyone is depressed. And we really were. I was actually just standing like right there. I had to walk out of the room because otherwise I would start crying. And I thought that was a bit it was just it was the end of a very emotional discussion about whether we should have a certain figures or certain numbers in there, and then it wasn't advancing, and then some delegation really said, okay, come on, we're playing games here, but actually there's people's lives at stake. And it was a really beautiful speech that someone from a developing country gave, and it was this kind of gives the emotion of such a session. All right, that's enough for the IPCC. If you want to have more questions about it, then feel free to ask, or now or later. So anyway, yes.
On this controversy about developing that.
Yes.
With potential finance flows to make up all of these different multiplication factors.
No, it was not about the multiplication factors of the figure itself. It was purely like the underlying discussion whether maybe Celine, you know this better than I do, but it was whether I think China is considered a developing country, and that has repercussions in the whole UN process of financing that goes way beyond just the investment flows of this figure. It's just in general, like if you're a developing country, then you get like aid and better loans and these kind of things. Yeah, but then it's explicit. It's explicitly stated, and the US, if they approve this figure, then there's an official UN document that has been approved by the official delegation of the US stating this, and that could then be used in some kind of law thing. Is that true? Is that a good representation of how it went?
Yes, I think so. What is a bit surprising is that it was exactly the same topic at the 5th assessment report and the SPM of Working Group 3. I was there in the French delegation, not as an officer, and it was this massive difficulty with a knowledge type figure that had also this developed countries thing, and it ran for the whole week of negotiation with some fighting involved, and it did not make to and we did it again.
Yeah, oops, we did it again. Yeah. I think it's I forgot about that. Yeah, thanks. All right. So I want to continue because I want also to give you time to do stuff. So in general, when you want to make a figure, you have to think about aesthetics and design elements. These are the combination of these two things, and I will go into detail what they both are, and just have a checklist in your head when you make a figure. How's my aesthetics and how are my design elements? Now, a very simple example, in the longer report of the synthesis report, there's a very simple figure. It shows, I kind of cropped the intent because it's a bit larger figure, but it's very simple figure. It kind of shows the reduction in emissions from different sectors. You have the reduction in emissions for 1.5 degree world. A reduction in emission in non-CO2, in transport, industry and buildings, so in the demand sectors, in the supply sectors, and in the land use change. Very simple. You can make this in Python or in R. You just have these lines and a little shade. That's it. But okay, so I was just using Matplotlib yesterday. I actually never used Matplotlib, so I actually couldn't get the shades in there. But at least if I only had the lines, then this is basic. I made it with PyM. It's a very basic plot that you get directly out of PyM. It shows the same information. Let's disregard the shades, but anyway, it shows the same information. But somehow you have the feeling that the plot on the right is nicer than the plot on the left. At least I do. But it is there's not big differences. It's not that you show a whole story. It's not that you have it looks completely different. It's just lines. But there's a few differences. So what are the differences now? that really make this up. And I think it's really the combination. Okay, maybe you can see what do you think are the most, what kind of tweaks should I make from this one to kind of get something that looks a bit more appealing? So what would be first step? Anyone? Yes.
Scale the y-axis makes it very readable. We don't know what's the information.
Yeah. Okay. So you mean that this is in percentages and that one is in absolute numbers?
Yeah.
Yeah. Great. Yes.
I like the names near the line.
Thank you. Very. Yeah, that's a very important one.
Names near the line.
Yeah. So put the legend where it's needed. Very nice. Yes.
Nice color palette.
Nice color palette. It's also important. It's something that as scientists we don't usually talk about, but it's very important. Yes. Yes.
Uncertainty ranges.
Yeah, uncertainty ranges, but that's my mistake because I couldn't do it in PyM. I don't know how to do that. Horizontal lines. Yeah. Nice. Yeah. Others.
The dots.
The dots.
Horizontal and the
Yes, exactly. And this is what I call design elements. That's not necessary for your data, but it helps the viewer to kind of see what at which point it's at net zero, which point it's a 50% reduction. All right, I think we kind of covered most of it. So if we disentangle that, there's two parts. So this, what I call the aesthetics is the colors first of all. So you talked about the color palette. That's one thing, but there's also the colors of the background. Like it's a different shade of gray compared to the color of the plot. Sometimes you can do it invertly. You can have gray as background and white around it. Doesn't really matter, but just think about it. There's the font is actually was different. The normal font, I don't know what the normal font is of Matplotlib, but I would recommend just to choose a nice font that makes a huge difference. In IPCC, we always use Frutiger. You can download it for free, or use Open Sans or something, just a basic font, and that is just already makes it look nicer. The axis we talked about, and in general, I would recommend to look around, look in papers, but even better, look in newspapers or look in reports, look for figures that are made by a professional designer, and kind of copy that style and adapt it, and just use it as your basic style when you make a figure. You can in Plotly you can make a template that all your figures are directly have a nice background, a nice font, these kind of things. But just choose something that you like, and then you can very often very easily apply it to your new figures. And I think newspapers are a good way to do that. But also these designs that are made by professionals. So by the way, I didn't come up with this. With all the figures that I made, they first like the professional designers, they made other figures in the report, and I just copied that style. I just made my Python script that copied it, but so it's not my thing, but I learned a lot from those professional designers. So that's aesthetics. Then the design elements. So the in-place legend, that I think is very important. I saw it already in a few presentations and in a few posters, so that's just a good job. It's not always possible, but in this case, it makes it just much easier to read. Visual aids, so the dots, the stronger, the thicker lines of the grid lines where it's needed. And this is something that I didn't know about, but have a common framework. Have a common framework between all your figures. So that means a consistent color palette. If something means oil is red in one figure, have oil is red in the other figures. But also in the synthesis report, I think they did a very good job there. For every time there was a 1.5 degree, there was this little box around the 1.5 degree that was blue, just to show that blue meant 1.5 degrees in every plot. Every time there was, over here, there's this little icon. I think that means that we talk about CO2, or we talk about emissions, something like that. So they have a little icon. It's consistent throughout the whole report, so you kind of recognize it. I don't show it here, but there's also a nice way to have annotations. Celine talked about it, that you have these little arrows pointing to something. I'll come back to it later. Please do that. Also, very much so in scientific papers. Just add a little annotation. It's not strictly necessary to show your data, but it's it really helps the reader to just navigate your plot. All right, so if you go to more detail into this aesthetics part, about colors, just choose a color palette that you like, copy it from somewhere, I don't care, just choose something that you like and make it consistent throughout your plots. Either have like a general palette for just general plots if there's no order, or create beforehand a color palette that matches certain, if there's like the color categories in IPCC graphs, they have a matching colors everywhere so that you kind of recognize it. So have that beforehand. And then choose something, yeah, there's two ways, yes, please.
Just a comment. You may want to use a colorblind friendly color palette because like it happens more often. I would think to have like authors or people really think about colorblind is right. So you may check schools like them.
Yes, so just for the recording. So yeah, you have to choose a colorblind friendly palette. And I will come to that in a minute, but that's indeed very important. Just to, if you choose a professional color palette that has been applied by some people already, then they have thought about it. If you do it yourself, make sure that it's color friendly, and there are tools for that online. Just Google for color friendly palette and then you'll find something. Now, in general, this is more of a color theory thing, so you don't have to remember it, but it's nice to see the background of it. Yet the two ways of choosing color palette. One is either you have few hues, so the hues is the colors basically, and you have more shades. So in this case, like the Financial Times uses only like 3 colors. Like they have the blues, the greens, and the purples. But within those colors, they have different shades. And if you look at all the figures by, I think by The Economist, just random figures, you see that they only have 2 colors actually in different shades. And you see that just, you don't have to look at what the figure means, but you see directly that they use just different shades to show the data, even though these 2 things, they're different shades of a color that they don't have anything to do with each other, but you still, it makes a very relaxed way of looking at the picture. Now, on the other hand, you can also do the opposite, like the Times, the journal, the newspaper, the Times has like 1, 2, 3, 4 colors. New America also like 4 color, maybe 5 color groups, and they have less shade. So they really focus more on the hues. And when you look at the pictures, you see that these are all colors that have kind of the same intensity, but that have a different color. Typically, this is a bit more difficult to make colorblind friendly, but they probably thought about it, so this should probably be fine for such a large newspaper. But you kind of see the differences there. It doesn't matter which one you choose, just choose one. Now, a few examples. I will show many of these not ideal and better plots. I took them from a blog from a data wrapper. I'll show the references. They have excellent graphic designers with very nice tutorials. But in general, it is nicer if you have a simple plot with a few variables. Just use shades. Just use different shades instead of different colors, because it just makes it much more relaxed. And this is the colorblind version of it. Then colorblind people would only see this. There's just no difference. And here there's just a very clear contrast. So use shades when it's possible. An example from the Financial Times, it just makes it more relaxed to look at. Now, this was a famous plot from the Financial Times in COVID times. It's a very complicated plot, but I really like it because, first of all, they have a nice intent. They have the message. What is the message? The COVID research varies across Europe. So they show all the different lines, show different countries. And instead of having all of them in one plot, there was too much. So they made different subplots and they kind of grouped them. So the countries with a large increase, with moderate, small, and countries that just stayed constant. So again, for the data that you show, there's no need to have these different palettes or different subplots, but it just makes it much more easy to read. They have the annotations, which I really love. They have the legends or the y-axis where it's needed. So on the right and on the left, it's the same, but it kind of adds it. But there was a controversial choice of colors here. Yes? Here. If they don't have the same color as Yeah, true. Yeah, so indeed, I actually like that. That please do have matching in the IPCC figure that I showed. That there were matching colors, so that could have been an improvement here. But the designers, there was a discussion about the design of this figure and some other designers. The design of this figure, he mentioned that. It's Steve. He mentioned that he just chose the colors to like maximize the contrast between the lines, so that it's very easy to read. But kind of says like, why is Italy in green? Is it better? Is green better? I don't know. Why is Bulgaria now kind of red? And is this blue, same color as that blue? So in this case, would have been better to make this figure. So someone else on Twitter like recreated this figure and only changed the colors. But now you see like the natural order of these colors. There's no, I mean, you can still clearly see which country belongs to which line. You kind of sometimes have to fiddle around a little bit. It's less easy to read, but it's more, it's less, it gives a less false impression that there's matching colors of the kind of thing. So yeah, it's a very nitty-gritty thing, but just keep it in mind when you make a figure. In general, use different types, like use 50 shades of gray. That's basically what this figure is saying. It's really okay to have grays. Please use a background that is gray or some surrounding thing that is gray, very light gray. It just makes it in general a bit easier to read and more appealing. So here there's the highlight of all the different colors of gray. So the axis has different gray. It's not black. For example, this one, the title is a bit more dark gray than the subtitle, just to give this order in importance. Not necessary, but it's just one of these things that some people apply. All right, that's about aesthetics. Now about some design elements. Some common ideas that you can use when making figures. We talked about this, label directly. So it's much easier to just label directly instead, and in the same color, by the way, than to have this legend, even though the default plot that we all make in our legends is just we have a normal legend, because that's what Matplotlib or R does for us. Now, another example is this is a bit difficult to read because you have to twist your head to turn your head. It's here there's an abbreviation which is also a bit better, but you still it's a bit more difficult to read. So then just turn it around. And this is something that it's not standard in plotting libraries, but just put your name next to it. You can still see the comparison. It's just an idea. You don't have to apply it. It's not always applicable. Just can be sometimes nice. So show information where readers need it. Second, repeat the units your data is measured in. Please don't just put 0, 10, 20 here. If it's in million US$, just put 10 million US$. Or in our case, very often, don't just put 0, 1, 2 and then degrees in the title or in the axis. Just put 0, 1, 2 degrees Celsius in the axis. It just makes it directly clear that it's temperature. Yes. Yeah. That it's in millions, you mean? Yeah, in the axis title. So you would write it somewhere here then. Yeah. Well, that's also good. That's also. I think I prefer this. That's, you know, it's just a personal preference. But just have it close by. Don't let the readers don't let the readers search for it. That's the most important thing in general. Next thing, use different kinds of fonts for what you want to highlight. So the intent or the title, here, there's great intent. Revenue increases. Very easy. And it's clearly that this is the title. Then there's a different shade of gray for the subtitle. It's a different font. Everything is the same font size, by the way. That's quite nice. Don't use all kind of different font sizes. It just makes it messy. And it's like a non-US revenue. This is like the most important part. It's in the same color. So yeah, it's just a small example that can help. I've 3 more, I think. Emphasize and explain with annotations. Annotations. Please use that. It makes it so much easier for the reader. Just have a few annotations and just make clear that it's an annotation, that it doesn't add extra data. It's just look at this, or this means that, or this means that you have to look at here, or look at the connection between these two things. And the message, talk about the message. Be conversational first and precise later. We showed it in the IPCC figures. The intent was like emissions need deep, rapid and sustained reductions. That's not everything that's in the figure. The figure shows much more, but that is the main thing. That's what's called conversational. It just reads nice. It's clear what the message is. Like on the left here, price estimates for multifamily rentals increased between 2020 and 2022. Okay, it's a message, but it reads very difficult. Oh my God, this is so boring. On the right, rents are rising everywhere. See how much prices are up in your area. Well, this is for a newspaper, so you won't do this for a journal, for a scientific article. But the idea is there. So make it. Don't use complicated language. Just in general, I think that when you write a paper, just make it in a very easy language. Even though we're all tempted to use nice words and nice sentences and long, nice grammatically interesting words, but the complication of your paper shouldn't come from the language, but really from the insight. And that's the size. So it's the same is true for figures. And the last one, so again, use straightforward phrasings. Central estimates of the average extent to which citizens of selected countries support a democratic political system. We've all made a legend caption like this. We've all done it at some point. That's something that is it's just very factual. It's clear. You're doing the right thing in a scientific journal. You say exactly what's going on. But here, US citizens support democratic systems less than Chinese citizens do. So you show directly the message instead of just a description. And then after that, you can go into the details in the caption, like what is exactly the colors, etc. All right, that's it. That's the main things here. That's some extra reference. I'll show you get the slides probably. I don't know exactly when, but so there's most of the links that the figures I showed are this from the data wrapper guides. They're just extremely useful, but there's more. This is an interview with Arlene Bird, who is the main graphic designer of the synthesis report. She's the designer of this first figure that I showed and that Celine showed with the warming stripes, and she got a lot of interviews for that. And she's really an amazing person that from like passion to do this, but also from her abilities to actually do that. So it's I learned so much from her. It's really, really nice. There's some examples. This is more from a scientific point of view. So science data visualization is also a nice guide, and some examples of more infographic styles in The Economist. The Economist are typically quite nice graphs that you can use as examples. All right, and a last example that I liked in the synthesis report. This is like an extremely story. Yes. Nice, that's great. Yeah, nice. So that's I didn't know that. But so in general, use something like this where you already have a fixed style that you don't have to do every time. Change font size, change color background, change. That becomes a mess. You have something that does it for you, a package, or in Plotly it's a template or whatever, or make a function yourself that you just have to call. I don't care. Just have something that is already there. Now this figure is extremely, well, I would even say conversational only, almost. It's really like a story that's being told here. So this is really the links between the different working groups that were shown here. So you even have I mean, in a normal scientific paper, you would never. I would never first put like a schematic picture like that, but actually do it. It's very, very useful. It says socioeconomic changes influence first the emissions. So we show the SSP emissions that change the climate. We show the temperature, and that which drives the impacts. We show this burning amber from the working group 2. So you really have actually in the sentence, you have a visual explanation of the sentence. Of which is the main message. So I think it's you really see the connections between the two. You have the matching colors. You even have a little line saying that, oh, hey, there's this uncertainty. These are the same C1, C8. You have this little annotation. So So this is the same graph that Celine showed with only the uncertainty of 2 of these SSPs. So for RCPs, one is 2.6, one is 3.70. And so you can kind of see the matching there. All right. Now, part 3. Now it's going to be your job to do something. I would like you I would like to invite you to practice creating figures. We'll focus on the aesthetic part, and then the design elements part. I would recommend that to do that in Illustrator or Photoshop. Who has experience with Photoshop or Illustrator or Inkscape, or ever used it? Okay, nice, nice. So you can already just use that to just so make a figure in Python, export it as SVG or PDF, whatever, and then open it in Illustrator, and then you can fiddle around and add the last details. Or if you're a huge nerd like me, do everything in Python. So, all right, creating your own figures. So we are. Oh, the title is from an old presentation, but so all these figures and the numbers in the AR6, they come from the database. We talked about this a lot. There's some pre-processing steps that have happened. There's the common regions, there's the vetting, there's the climate diagnostics, so the different climate categories, and there's some metadata calculations, like things that you can do yourself, but that have already been done for every scenario. There's like, what are the cumulative emissions? Of course, you can add them all up, but it's nice to have the cumulative emissions already there. Net zero year, year of peak warming, but also some real metadata that you cannot calculate yourself without doing a lot of things, which is like the baseline reference scenario. Was it you who did the baseline? No, you also made one of these metadata columns. I don't remember which one. It was a pain, yeah. So I think Celine and a few others went through every single scenario and looked which baseline, which reference scenario it was. So they're kind of matching different scenarios to see what the baseline scenario is and what the mitigation scenario is. It's something that you cannot see from the data, but that you have to go through every single one of them. And thankfully, Celine has done that, and it's all in the metadata, and you can use it now, which is very nice for if you want to calculate GDP losses compared to baseline and these kind of things. Now, it goes all into the AR6 scenario database, freely available, publicly available for everyone. When you download it, it looks like an Excel file. You have we talked about this. You have basically different columns from some kind of data first, some kind of explanation stuff, and then the actual data behind it. In the metadata, that is what I want you to focus on, because we spend less time on that. The metadata, it might be even more important, is when you download it, you get the Excel file from the database, but also a separate Excel file from the metadata. And it has the same model and scenario columns, but then all the different metadata columns. And just once have a look at all the different metadata columns that are available. You'll see that it's a huge amount of information. There's even information about what kind of technological assumptions are behind a model. It's something that you cannot calculate, but it's something someone had done that before. And it's just a gold mine of information. And I'm sure if you go through that you can find ideas for making papers that have not been published, that have not been done yet, and that you can make a nice analysis paper on that. Now, about the code that we will use, unfortunately, I'm not a PyM. I wasn't a PyM user when I started, and I did kind of the same trip as Daniel did. First, I was making the scripts to make the figures and just calculating everything, and it was a big mess. And then it turned out that I had to do something for the IPCC a little bit more seriously. So I kind of made my own package, which is unfortunately very similar to PyM, but in this tutorial, we're going to use my package because it's more focused on the figures, and but you can all do everything with PyM as well. It's just that I'm not a big user of it. So anyway, in my package, briefly, the idea is that you have a data var, so a data variable object. This is where you do all your calculations with. So you can select a certain variable or in a certain year in a certain region or combination of variables. And then you can do your calculations. So you can, if you want to divide CO2 emissions by I don't know, by GDP to get some kind of carbon intensity. Then you do that with the data for CO2 emissions divided by data for GDP, and then you get like the combined part, the calculated part. I'll show you in a minute. Once you've done all your calculations, you have to do the selection. That's what PyM calls the filtering. And the filtering is usually based on the metadata. So this is really where you use just the data. This is where you use the metadata. So I really made the distinction. First, you do the calculations using the metadata, using the data, and then you want to add certain extra information like which climate category, or if you want to only have C1 and C2, or if you want to have information on what the cumulative emissions are, you can just add that all there. The examples in the notebook that I will give to you in a minute, you can just follow along. You just press enter. You don't have to, and then you can play along if you play with it further later. A few examples. So data for emission CO2. Here we don't do any calculations. We select everything. If here we just take this emission CO2, but only in one specific year, and then we add the metadata column category. And we don't do filtering, just want all of them, which means that we just add a column with the column category. Here's the same, but then we only want C1 and C2. So it's kind of a bit straightforward. Here we do first this calculation. So in blue, data for emission CO2 divided by data for emission CO2 in 2020. And only once we've done the calculations, we'll do the filtering. Now, what this gives you, the result of this is always a pandas data frame. And that's the starting point of making a figure. So you make a data frame that's just true in general. First, you do your selection of your data, then you put that data into a figure. Please don't try to merge it. Please don't when you make a figure, then when you say X equals, or the X value should be, and you do a calculation there, that's never reproducible. And you should just have a very clean data frame, or anything that in between the steps of making your figure. So before you make your figure, you need to have a clean data file. Because in IPCC, for example, you always need to put your data on like the data that's behind your figure. You need to put it on some kind of repository, which is a pain in the ass to do, frankly. But at least then the data is always freely available. So if you do it directly, if you already know what the data is going to be, save the data as output. You can always reproduce it, and then start your figure with the data that you just saved. All right. So in this assignment, you will reproduce a chapter 3 figure and hopefully improve it, because the chapter 3 figures don't have an intent, for example, and they don't have good design elements. I can say that because I made them, so it's I can criticize them. And there's a lot you can improve. But so first reproduce it and try to improve it. So there's always these separate steps. First, select your data using this data var.select, blah, blah. Then make your figures. We will use Plotly. I would actually recommend to use Plotly because I love it, and that's not enough. But nowadays, it's figures are not primarily made anymore for printing. Matplotlib or R figures, except for Shiny, but typical R figures and Matplotlib figures are made for printing. So that means that the units are in millimeters. It means, most of all, that they're not interactive. Whereas in Plotly, it's by default interactive. You can zoom in, you can highlight things, you can add or remove certain traces, and out of the box. And we use it in our team more and more to share, instead of sharing a figure like a PNG or a PDF, we share an HTML file, which is the output of a Plotly figure. And then everyone can directly select only a few scenarios, or only a few colors, and then it makes the analysis much easier. If I have to send it to Detlef, and Detlef says to me, "Oh, but can you only show one color or one scenario? Can you highlight one?" Then I have to make the figure again. Whereas if I send him a Plotly file that's interactive, can directly click it on. So I think it's a nice. It's not only Plotly that has that, but just think of this interactivity. I show the syntax in the notebook, but it's quite straightforward. You can make a line figure, a scatter plot, area plot, bar plot. There are 1,000 others. Just play around with it. Then I want you to, it's very important, add an intent. Intent is just a title of the figure, but think about what the message of your figure is. And you can choose between these figures that already gave you like the framework of how to make the figure. You can also choose another one. You should be able to reproduce every figure from the chapter 3, basically, more or less. But here's a figure about the IMPs, the different emission types in IMPs. There's one which looks boring, but it's very interesting. It's more about the drivers that are behind each scenario. So it really shows the different groupings. So this is population growth and GDP growth, and you see that it's all centered around the center SSP2 values, whereas SP1, 2, SSP1, 3, 4, 5 are just much less presented. There's a complicated figure with the different emission categories that you can easily reproduce. These are quite fun to make, actually. For example, what is the carbon intensity as a function of cumulative emissions? What is energy intensity as a function of cumulative emissions? And a few others. And this one is also quite nice for the different IMPs, like what are the different primary energy characteristics. And I can promise you, you can make each of these figures roughly within like 10, 15 lines of code, so that at least the basics, and then you can do the rest later. All right. What time is it? Until how long? What time do we have? We have half an hour. Okay, cool. So with 1 hour still. Okay, so what we're gonna do? I'm gonna leave this one up here. We'll have 5-minute break to go to the toilet and to get some air, and we'll start again in 5 minutes. Then I will walk you through the steps. If you want, in the meantime, you can already download the workshop files, which are on this link. It's this QR code. You maybe already have the AR6 database. If not, download it from this link and download the file AR6 scenario database world. Make sure that you have Python already, or if you don't have Python, find someone who does and then work together, maybe even nicer. Install Plotly, either pip install Plotly or conda install Plotly. And then out of the zip file that you download here, open Jupyter and open the Workshop Summer School notebook. There's also the Workshop Summer School solutions in there. Yeah, don't look at it if you don't want to have directly the solution. But if you want to have a look later, then you can do that. And yeah, we'll continue in like, let's say at 10 past 12, we'll start again, sharp. Okay, thanks.
Switch it up.
Lights blinking.
Yeah, right.
Okay, so if you make sure, so please make sure that you put your workshop files, you unzip it in a location where you can find it. In my case, I will just go to it, project meetings, blah, blah, summer school, workshop, and then open the workshop summer school.ipynn. Then you also need to make sure that you install Plotly beforehand. If you don't have Plotly, just open your Anaconda prompt and then just the conda install minc Plotly. But I will leave that later. And then once you have this notebook open, also make sure that you have the IPCC database somewhere, and it's unzipped. So in my case, I have it somewhere. Let's see, I think I put, it's easier if you put it in the same directory, but for me, I have another one. It's in databases, snapshots, blah, blah. So make sure that you have this folder with the file, the metadata indicators, and the database, or the database world only. The regions is not necessary. Because in the first thing is just importing the different packages. And there's a whole blah, blah, blah that you can read if you want, but that I will skip for now. In this first one, it's quite important that you have to specify which folder your metadata and your data files are stored. So if you put them in the same folder, you can just put like a /. If it's in the same folder, if you put it in, I don't know, downloads, you can do C, I don't know what it's called, users, the username, downloads. Just find the path of where you put your folder. In my case, it's this one. And then you should be able to just run this. And then you import all the data. It takes a while. It takes maybe half a minute, depends on how tired it is. And once we have that, so what it does very briefly, it first imports the data. Just this data is just a normal data frame. There's nothing, it doesn't do anything with my package. Data is just your average, your data frame as you would import it directly. Metadata, meta is the same. You also have a data frame with all the different columns of your data frame, of your metadata. And I did some selection that I only chose the scenarios that are vetted here. So you don't have to really follow along, just accept it. And if you want, you can have a look at what is really being done there. And if it works, then we can run this. So we have the data var, we just select a variable emission CO2. We do .select. Because if we don't do that, we still have like a random object that you cannot really work with. Then it's the same as a pym object. You have an object that you cannot really do stuff with in other packages. So you need to have the .select with it. And we'll look at it later about what it actually does. So it works, it doesn't give an error. If it does, then after this, come to me, then we can fix it. We'll try. So the first one, I want to give an example. Is so if you go to example, I'm sorry that I already started. So it's I want you actually to make a very simple figure like CO2 emissions per temperature category. So what we do always have the first step is to create a selection. The selection was by doing the data var .select. Well, the variable name, you should look up in the database what is the variable name. By the way, your zip file that I sent, I have to find it again. What was it? Project meetings, summer school, workshop, and it includes 2 CSV files, data variables, and meta columns. Those are just a selection of all the unique data variables in the database with the number of scenarios that mention it. So just have a look at this. See, it's huge, and this is everything that you can use to make your plots. So it's a great amount of information. But what you'll see is like primary energy, the variable primary energy has pretty much all the scenarios mentioned in it. But if we go into more detail, I don't know, primary energy from non-biomass renewables that's used for geothermal, that's only 86 scenarios do that. So it's much less. So sometimes you have variables that are more popular or that not all IEMs actually report. So have a look at this variable, this sheet. Also have a look at the meta columns. This is even more important. This is just, you can also open the meta file in Excel. Then you look at the columns, but this is for me an easier way. I just copied all the names here. So there's things like year of peak CO2 emissions, can be useful. There's, what is it again? Like literature reference. Oh yeah, there's if it is what kind of paper it's published in, what if it is an IMP or not, what the policy category is that COVID explicitly modeled or not. So there's a lot of information in there. All right, let's go back here. So the idea was to make a plot of CO2 emissions over time. So we look in the variables, we go to the variables, we look at for CO2 and something like emissions. Well, that's a lot, but probably with the E somewhere. Oh, here we go, emissions, CO2. So we just copy this one. This is an easy one, you probably already know it, but for the more difficult one, it's nice to select. We do the dot select, and then the category is all. That just means that we import the meta column category. And we have indeed a data frame with one column category. One column is the name, which is the combination of your model and your scenario. One column is a year and column of your value. Then the next step is plotting it. And in plot, this is basic Plotly. So nothing to do with my package. It's just vanilla Plotly how it works. And what you do, you have, you might want to make a line figure. You want to give the data frame that you want to plot. In this case, it's selection. For the x-axis, you want to specify a column name. A column name in this case would be the year. So we do year. Or for the y-axis, we need the column value. For the, we kind of need to group, like when does the line stop? It shouldn't be going like this. I mean, we should group the points by their name, which is this column, and the color is this column category. So again, Plotly doesn't know anything about categories or about CO2. It just knows about one data frame with the certain column names. We run it, and it might take a while because there's 1,200 lines that it wants to plot. And if your computer doesn't crash, you've got a figure which is nice and interactive. If you only want to look at the C1 scenario, you double click on your C1 and you only have your C1. You want to add C3 if you want to compare the two. Well, it's nice. I mean, you still have this overlapping line, so you can make it nicer, but at least you have something to work with. And it is already in this kind of same IPCC style. You have the background color, you have the types of gray. In my case, you have the font. You probably don't have the font installed, but if you want, you can install it. All right. This is an exercise that you can do yourself. It's making the same one, but then with the temperature. I will skip that for now. A second example is to make a scatter plot. You will use that for when you recreate your figures. In this case, we do the data var. Instead of having emission CO2, I just chose a random variable that was final energy, residential and commercial, and residential. So this is just the final energy of the residential demand sector. And I only want those values in 2100. Because what I want to do, I want to see if there's a correlation between the residential final energy demand and the median peak warming. Because it might be that in higher warming scenarios, you need less heating, for example, or you need more airco. So then maybe there's a relationship there. So we just put the variable here. Again, we do the selection categories all, but we also want the metadata median peak warming. It's an ugly name, but just look in the file to find it. We just run it. And again, we have these two different columns that we can use for the plotting. Quite straightforward plotting. PX scatter your data frame, which is your selection here. On the x-axis, we want the median peak warming. On the y-axis, we want the value. And the color, we want to color it by category. And what we get is this very nice figure where it's kind of weird. We see these lines. There's no single correlation with median peak warming. It kind of could be expected. It's not something that is very strongly related to temperature, but still. But then my question would be, why are there's just these lines here and they're not dependent on category, but actually maybe they are dependent on the model. So instead of showing by category, we can also include an extra metadata column, which is just which model it is. So model all, and then we have an extra column here, model. we can use that column to, instead of coloring it by category, we can color it by model. And then what we see, quite funnily, is like a very strong fingerprint of the model. So basically the median peak warming of your residential final energy only depends on the model and not on anything else. I thought it was a nice example. Good. You can have these insights from here. This I will leave to you. You can make the TCRE relation. It becomes very nice straight line between cumulative emissions and temperature. So it's a great figure. But I want to go now to let you work yourself. I know I'm going very fast, but just you can follow the steps and just read them yourself. Please use one of the following figures or choose another one. But for this, I have for each of them I already checked, and it's very easy to reproduce. Choose one of the figures from the chapter 3. You can download the PDF, but I also put the figures here. Choose one of those figures, and then just reproduce it. So in this case, for figure 3.8 with the different IMPs, I give you a few tips, and then follow the tips. Always follow the 3 steps. So what were the 3 steps again? First, the selection, then the figure, then the intent, like the title. So first the selection, then the figure, then the intent. And you can do for this one, you can do for all the different figures. Just choose one that you find is attractive, that you think is interesting or nice. Reproduce it, and then make new figures and create new insights. All right, I just walk around if you have questions, or you can directly apply this for your group work. Nico is completely. Yeah, of course it's too fast, but it's just an example of what you can do. So just do it in your. Just follow the step. There's much more explanation in this notebook. All right, what shall I leave on the screen? Or just raise your hand if you have a question, and, or if it doesn't work, or if you want to. Yes, Nico.
I failed with the first line. Because it says something like module not found error.
But did you unzip everything in your in the same? Can you show the folder where you unzipped it? Where you opened this? Ah, okay, but
So
you opened
here-
it from. You didn't unzip it, I think. Yeah, no, you did. But this file is not the one that you opened in Visual Studio. See, this one is in local temp blah 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 in your zip file still. So I would close this one. And then, don't save. And then open another one. Or just drag and drop this one into Visual Studio. Yeah. And then try to run it again.
So here?
Yeah.
With this, yeah?
Yes.
You have to know I don't use Python, yeah?
Yeah, that's okay. That's okay.
So
And then just
select another kernel.
no, just do okay. That one is good. Yeah. Okay. No errors.
Okay, good.
Very good. So there's all kind of.
I think I was too fast now.
No. This is good. This is all just blah 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 blah. You can read it if you want. Here you can. Now it's
Yeah. This is I have to correct.
yeah. Yeah, all right, I'll leave this and then if it doesn't work, then just call me.
I have everything on this desktop.
On the desktop? Okay, cool.
And when I run it, it still have the same error. I don't know.
Wait. Where did you, if you open it, is this your, yeah. Oh, oops, I did something there. Yeah, so the file that you opened, the notebook that you opened is located in your user folder and not on the desktop.
Okay.
So I think if you go to desktop, it should also be somewhere here, right? You unzipped everything here.
Yeah.
Oh no, it's not in here.
Okay, I can try it again.
Maybe you can put it in downloads or somewhere else. Just make sure that you put everything in the same folder, and then that you open that so that the notebook has to be in the same folder as all the rest of the things, specifically the AR6 utils folder.
If I extract everything again from this stuff and replace it, shouldn't be any problem, right?
No, shouldn't be any problem. No,
So I extracted everything now.
it's on the desktop.
And then desktop.
Yeah, but this is probably a different desktop. I'm not sure how that works.
Okay.
Maybe it's on the OneDrive. Yeah, can you instead of putting it on the, can you maybe put it? Wait, is this your? Are these your? No, these are not your documents, right?
No.
But in the, do you put everything in your OneDrive maybe?
I can. No. A Dropbox maybe I can.
In Dropbox? But do you know where these folders are?
Oh yeah, I know.
Well, just put it then there.
Thank you.
Yeah.
That's for some reason it does not give make the input.
What's the error?
Yeah, I think it is simply I forgot this
None.
backslash here.
No, this is weird. In the columns. That's a very strange error because I think this is good.
Yeah, I think the backslash is missing here.
But then now, oh, the backslash is missing. Yeah, is that?
Yeah,
Oh,
and,
how do you
and it does not work.
Why not?
I don't know.
Why is it an insert? It looks like it's in. Oh, but it's in. Do you have like a weird key mapping that it's on Vim mode or something?
Yeah, I guess it is on the Vim mode. But
I love it that you have the Vim command.
yeah. Here we go.
Now you're in a. Oh yeah.
So
No, you need two. You need two.
I need two.
Yeah, but now you can escape the backslash or the. Yeah, and now.
Do I have to have two here?
Don't think so. But I think this should be actually okay. What is string? Is that control?
Control, yeah.
Oops.
But now you are in the insert mode.
This is.
But he went to here. But he.
This is so strange.
Data import data, and then this is where the error happens, right?
Yeah, so it's an import data. But wait, can I just? I think if we just do pd. Oh, it's in pd.read cs. Where's your underscore? Read CSV. Oh my God. And then where's my quote? Where's a normal quote? Yeah. Oh no, I don't actually need it. I just need date folder plus data file name. What is delete? And see, this is not going well. It's because it seems to use maybe this is because of a language thing. On the default, it uses the point comma, as a tab separator.
Okay.
What is it?
This is this terrible German thing that we have the different separators.
Yes, I think that is the problem here.
Yeah, usually I use the semicolons. Yeah.
Yeah, semicolon. That's what it's called. Yeah. So see, this would work. All right. I'm not sure if I open this, if we can directly. No, we have to kind of do it manually now. Sorry about that. That was not implemented in my package because I had never had that problem and I was the only one using it.
Yeah. This is like backslash and slash.
Exactly. Delim.
There's no intelligent solution for this terrible problem.
It's such a stupid thing. This should not happen in 2023, right?
Should not have
The limit.
2010.
That's true, but now it's even worse.
25 or 1990.
Delimiter.
And I think the mistake was done somewhere in the back in the 80s or 70s even.
Yeah, probably. All right, so just try it again. I restarted your kernel, so you have to run the first cell again.
Okay, but then this part should work, yeah?
I hope so. The whole thing should work, but all right.
Sorry, it doesn't show it either here again. Like I put it in Dropbox.
Can you show where you put it? How you did it?
Dropbox. Model, and
Yeah,
everything
okay.
here.
But is it the same as?
Everything is the same, but it doesn't read the rest.
Okay. If we make a folder that we call, okay, untitled folder, does it now show here? Where is it in add merge 2019? No, but this is a different, see, this is a different folder.
How is it different?
I don't know, there's many more, it's a different location. There are many more files here.
But how does it go? How does it?
Like this merge thing, merge ETL.
Yeah.
It doesn't show here. So. Oh, no, it doesn't work. Oh my God. We have to be able to solve this. Do you know where these files are stored?
Well, we can check it out.
Yeah. So maybe try to find those files and put it in the same as that. And otherwise, we might have a look with someone else. That might be easier. How's it going?
I was using Jupyter Lab and the plot just didn't show up. So I'm trying to account notebook.
The plot didn't show up. Did you get an error or was it?
It was just like a full space of blank.
Ah, okay. We can probably fix that. It's probably too complicated for the computer to show that it kind of crashes, but yeah, it's still doing. No, no.
Okay, so for notebook.
Okay, well then that's solved. Nice. Which one? Yeah, that's my own package.
But it's on frontline stuff, or is it a IPCC? You just provide it, right?
Yeah, I just provide it, and it's not on PyPy or on Conda. Or it's just that I only made it for myself at some point, and then. But now my students is also using it, so I might. But that's kind of this awkward position with PyM versus my package. I just always use this one because for if you want to do calculations, this is like 10, 20 times faster than PyM. Yeah, and the selection and stuff. PyM does kind of extra checks, so it's probably better, but it's more historical reasons. Does that work?
So if you
Oh, you need to install. Did you install Anaconda or what did you install? It's okay. Then you can just pip install ipykernel or just press install. It's probably enough.
this is I don't know. I've never used it.
Yeah, then it's then this thing is required. It's a high activation energy required for. Oh, that wasn't too difficult. It's working. Okay, cool. Now you can do so this is all blah blah, and if you go to the first input cell, which is here, there you need to still specify where you put your data folder.
But I downloaded the folder, I loaded it here.
Well, that's, yeah, it's relative. Or it's absolute, whatever you like. If it's in the same folder, is it the same folder?
So I mean, I downloaded, extracted it here.
Where's your data then? So you need the AR6 database.
This one, so I need this too, right?
Yeah, need to extract it, put it maybe in the same folder as the. Yeah, that's great.
So I have another small question because I was trying to get a list of variables, the list of scenarios for each variable, and that's my useful information. I could not get it to Python.
The list of scenarios for each.
Show this on the data.
I only have that only shows the number.
Yeah, but it's very useful. I mean, it's very useful.
Yeah, this is super easy to
but
do.
how do you get it?
I just well, if you just do when you import it. Let's just do it. Let's just it's very easy.
No, but I in Python.
No, it just when you import what I did, I imported the file. Then you have like a data frame, a pandas data frame.
This one.
Yeah,
Okay.
that one, and then you can do a group by
Because
variable, and then dot sum, and then you have.
but then you have the world data because if you query this file in Python.
Yeah.
Like, I mean in Python. In R,
It crashes. But that's why I don't like PyAm, is that it takes me 20 seconds to load this.
Because you have a snapshot. You don't use the API then. Okay.
No, I don't use the API. That's because it's 300 megabytes. It's very easy to have locally.
That's why I mean, there was no way to, because to get the number, I would need to import all the words.
Yeah.
And then do the group by, which is easy, but so I mean, this is.
Yeah.
So
And even the regional file is
regional.
no, it's fine. My students always use the regional file to make their plots locally. So.
Download it from there, I see, but let's
Yeah.
see, for instance, we use in project, we use the upload data, we have to use the API because.
Okay, yeah, to upload, yeah.
It works, but when you have too many variables, and you need to ask all the variables.
Okay. I didn't know actually about this API, but I use it mostly in the train, and then I don't have.
AF6, I mean, it's
Yeah.
static, so you don't care. But
No, exactly.
all the projects we use, the folder should be just this one, right? I mean, it's local.
Oh, this is absolute. So if you do dot slash.
So yeah, that's the API bit. Yeah, but project you need to always update it because they always have people updating that.
Yeah.
But it works very well. So data bar is your function in AR6.
Yes, that's and when you do data var, that's where you do your calculations, and then you do dot select, and then you get this is normal pandas output.
Right. Yeah, sure.
Yeah, it's the other way around.
And then so you have
Emission
so
future.
so in your package because how you deal with how you combine the metadata CSV and the whole data CSV.
It's linked through you see you have this column name that doesn't exist.
It doesn't exist in the original one. So
Exactly. So it's
just a concatenation of the
just a concatenation of model and scenario
space in between.
with the space in between. I mean,
And then
Daniel was annoyed by that.
I can see that, but I mean it's needed because otherwise you always get messy.
Exactly, and this is like a single index. And you can use I tried it once. You can use multi indexes, and it's a mess.
Yeah, but I can see that. But then, so how you in the package you kind of merge that with the metadata, right?
Yeah.
That's all. I mean, it's a bit because otherwise you always have to merge it or either stuff or either
Yeah.
ones.
And so I mean, it's just what Daniel said. You can easily do it yourself, but
Yeah, but I mean, you need to do down.
what's going on? NB format. So can you just install NB format?
So every format in,
I don't know what it is. It's probably because I think to use interactive figures in Visual Studio Code.
I can ask you one.
Yes.
So I never use Plotly. Does it work only in Notebooks?
Good question. No, Plotly works if you just do normal Python script, you can save it as if you save it as a figure, and it saves as HTML, and that you can open in a browser.
I see.
And you can. It's also for R and for JavaScript for any language or Julia. You can use Plotly, and then it just outputs an HTML or an SVG or PDF, but mostly it's HTML, and that you can open in a browser.
I use it in PyCharm,
Yeah.
but of course it doesn't open on this side view. Well, you can.
I think it should. I think a PyCharm should. I think that you need to package NB formats because that's what they use in Visual Studio Code. Because by default, Visual Studio Code also doesn't open it. But if you have NB formats, then you can. You just need like this interactivity. It's a normal basic HTML that you need to show in
the notebook.
Oh.
In the normal script. If I run it like in the console, the Python console.
Yeah.
Doesn't go through the but I mean it's okay.
Yeah, just save it. Yeah, it might be possible. I just don't use PyCharm. I use Visual Studio Code. And
just search for it. I think just need to find it right.
Yes, like that. Hey.
In these categories, like so these ones, right?
Yeah.
So to know, like, to not be double counting.
Mm-hmm.
Like if you have like this category and then it's split up into these two.
Yes.
So this should be the sum of. Like
yes.
That, but there's a limited number of scenarios that make that split up.
Yeah. So that's annoying.
Yeah, and then for this one, then there is. So this is a category that has like, there's no forestry, like names, and then there's only like the. Do you see what I mean?
Yeah, yeah. So actually, in this case, so this is really more of an IAM question that you should ask people who make this model.
Okay.
But in this case, I think you can just add up this one, the forestry harvested area, plus managed, plus natural forest. I think the sum of these should be the same as that forest.
Yeah.
Even though this one doesn't have like, there's not one forestry. Yeah, because there's the same problem with BECS. There's no, I think it's called BECS, is like carbon sequestration, CCS, biomass, something like that. But there's no carbon sequestration, CCS, just or something. At least there was an example there where it doesn't have the parent variable. All right, work. Yeah, in a minute. Wait.
So I have no idea.
Did you have the notebook open? Okay, great.
It's not great.
And if you run this, what happens?
Nothing.
What nothing? But that's the. Wait, can we stop that? This is the debug way of doing it. Oh, here. Can you press the stop? And can you now press this one instead? Oh, yeah. Okay. Now it gets an error. Module not found. NumPy. So you need to install. How did you install? Have you used Python before? Not really. So so you just installed Python from the website, or did you install Anaconda?
Yeah, I installed Anaconda. So.
Oh. Okay, so maybe it's easier if we just wait. Can I try something?
Yeah.
So we open the prompt. Oh, this command prompt. I don't want that. Anaconda prompt. I'm just going to check something. That's not what you have to do, but I just Python import.
Is it better to use the
No.
prompt than the?
Oh, so this works. So there's different Python versions here. So we're going to fix that. We're going to just open Anaconda and navigate. Just open Jupyter.
It's better than this one?
Yes.
Okay, why?
Because then it already knows what Python is.
No, I mean when I work with
No, then it's not.
Okay.
So what I did, I just opened Jupyter. You opened it in Visual Studio Code, which is great, but then you kind of have to tell Visual Studio Code where Python is, and that doesn't really work. Yeah, this should work better. So can you go to the folder where you put where you saved your stuff?
Yeah.
You have it here. Okay, and does this work? Oh, sorry, you scroll the other way around.
And no, it says that it's not connected.
Okay, we're just gonna close this one. Let's go again. So it's in OneDrive, I think.
Yeah.
Yes, this looks very good. Let's try to open this. Let's try to run this. Yeah, now it works. Doesn't give an error. You know what I did? Exactly the same as you did, but now it works. I don't know. It's weird, but at least it works. You can continue. All right. Ooh, nice. Yes, yeah, in a minute. But just a small question that I want to stress again. Two things. What I want to repeat what Daniel said last time. If you make analysis scripts or if you make figures, make sure your code is clean at least when you're finished, and then use versioning control for your figures as well. It's very important. And secondly, it can just be easier to first make, so again, I said it already, but make your figure in Python and then open it in Inkscape or in Illustrator to do the more design stuff. But that's whatever you like. Yeah, in a minute, I'll just say.
I mean,
Does it work?
It's a very, very, very jump question.
No, that's probably not.
I mean, we can do here these selections, yeah, data var.
Yes.
And which variable and then which selection.
Yes.
How do I see here which variables I have on the menu?
Yeah.
And which selections I can do?
Yeah, good question.
How do you
So first of all, you can just open this file in Excel and then
yeah,
filter it, or you can open exactly. But that's the noob version to do it. But oh, it's not here. But in the same folder, if we in the same folder, I already made exactly that for you. A data variables and a meta columns file. If we open data variables, you can just look all the variables that you can choose from what's on the menu, and all the meta columns that are on the menu.
Yeah, exactly. This is what I'm.
All right.
Okay, in the AR6 appendix, I can see what all that means.
Yes, exactly. That's not a question you should ask me.
but
You know that better than I do. But this I know. No, this I know. The meta I know, but the variables, you know that better.
I don't have a function that says which names I have.
Yeah, you can do that.
How do I do this?
Well, so you imported here your data.
Yeah,
Data is just a data frame, right?
Yeah, like in R.
Like in R.
In R, I have
data.
in this
Oh my
R
God,
studio.
Data, and then you want how do I get this one?
This is this.
The Altgr. Okay.
I also don't know what it is. That's the Altgr.
Altgr. Yeah, exactly. Variables. I want the column variable, and then I want to do the .unique, for example. And then you get all your, and this is just a very long list. You can print all of them. You can print it to a file, and then you have, so with the command, you have all the different.
Unique, and I can also grab, I guess.
But you want to filter through it.
Yeah.
Yeah.
So everything related to emissions.
Yeah. Well, so I would again just Control F in that file. That's much easier. But if you want to grab through it, yeah, we can do it.
Yeah, but this is all your package. What we
No. So this is just pandas. This is just pandas is the data frame thing. So that's the nice thing. I try to keep my package as small as possible.
Okay. How can I see which? I mean, for example, yeah, in R, yeah, I have the help, yeah, and then usually I have something deploy, yeah.
Yeah.
And what I find very comfortable is I can simply ask index for deployer.
Yeah.
This data manipulation.
Yeah.
And then I see all the facts. Can I do this also?
For my own package, no. But I made a reference file that has that. But if you use PyM, you can. But it's just that my package was never meant for other people to use, so I don't have all this documentation and stuff.
Okay.
But there's one reference file. There's a link somewhere in the document.
And it is only the functions that you did. Simply the enumeration that I see.
Yeah. So in Python, the way of Python to do that is, I think, dir AR6. But I have hardly any function. I only have data var basically. So everything is through that, and a few plotting things. AR6
yeah, but this px dot lines, for example.
Okay, that's something that you can find the index from. But then it's for Python. It's always online.
But this is not your function.
No, that's Plotly Express. If you just Google for Plotly Express, we'll see. Oh, it's a different keyboard. I mean, even the Z is a. And then here you have an overview. Here, this is all the functions that are available, or the types of plots that you can make.
Plotly, okay.
See the PX scatter line area, and then you can just click on it. You have a reference, and you can.
Yeah, for R, I have the GG plot.
Exactly. Yeah.
A PDF file, so to say, GG plot for dummies, which is very helpful. So
With Plotly, you also have a Plotly cheat sheet somewhere.
yeah, it's even better than a cheat sheet because it really explains you all the dummies of the dummies.
Yeah, yeah, but exactly, that's super useful. Yeah, but the way that they do
I
it.
have recommended it very often. I found many friends
Yeah.
recommending that one.
Here they just do it through examples. You know, you just examples and you follow it.
So you don't have, so to say, which function? So you have this data select.
Yeah, that's basically it.
This is the basic function that you added.
Yeah, because it does calculations and selections, and the rest I just do using the normal plotting function and normal pandas.
Okay, you also there have the renaming or something.
If you want to rename, you have to do it yourself. In general, I mean, PyM is really better. It has renaming and the units and these kind of things. My package it is much faster. I mean, it's super fast because I needed to be on the fly during an IPCC session to quickly do some calculations within half a minute, and I cannot wait 1 minute for PyM to finish the calculation.
Oh my God.
So,
okay, now you are my hero.
yeah, well, this was really happening.
You did that, really?
Yeah.
During the session.
Yes. Okay, one example. This was
So
crazy.
You were super laser focused.
Super focused. Then Detlef and Malte and people, they said, okay, we need that. Then I was quickly, okay, then I quickly show this, quickly calculate this. And then after that, and then that's why I needed to have a package that I could rely on, because if I do that using my own calculations, you make mistakes. Whereas if you, I just want to show the syntax, and that's a mess, right? But if you, let's see, I don't know where maybe there's an example. Maybe it was in, anyway, but if you just want to do a division of things, you just do like data var, this data var divided by, you just data var divided, where's the division?
Here.
Yeah, divided by then data var
population, for
population, exactly, population. And then you just close it, Control Enter, and you have your values directly.
Okay,
So and then you here you don't make a mistake that you have a different index or anything. It'd be less mistake. This is something.
And we are also able to do this, for example, you can also say, give me the average of all models.
Yeah.
For example, but the categories.
So if you want to buy model or of all of them.
All models.
So of everything.
Yeah.
Then here you can do you can, for what I would do for every year, for example, I would just remove the dot head. Well, I can do it here. I would do a dot group by because I want to group by year. Group by. This is just basic pandas again. So it's not my package.
The group by is also
group by is
also in R.
Yeah. So
very useful function.
It's amazing. Yeah,
it's so useful.
Year, and then you take the value column.
With our kind of data that we have, it's really amazing.
And then dots. You said mean dot mean. You said the average or dot median. I don't like mean. Dot median. Or you do
mean,
and then you have your values over the years. Or for all of the years, you can.
But you don't have it now for the categories.
No, you want to do by category? That's a group.
The category that would be here, so to say, interesting also.
Yeah, year, comma.
Okay.
Got category. Category.
But I still have to tell him first category all.
Basically,
the information.
Exactly.
Then, okay.
I'll remove the head. Head just takes the first lines. So now you have everything.
This is
and that you can plot and.
And here I could also multiply with 1,000, for example.
Yeah, exactly. Just do times 1,000. You can also do it here already in your calculation. which I find very useful. Yeah, it was just this high pressure situations on the podium that you really need something that's that kind of works.
Oh my God, programming with the spotlight on you.
Yeah. Okay, another anecdote on the synthesis report. It was supposed to finish on Friday for the whole week. I finished on Friday, so I booked my night train on Saturday night at 9 o'clock in the evening. Now, it continued on Friday night, the whole night, no one slept.
Where was it?
In Switzerland,
Okay.
Interlaken. And on Saturday at 7 in the evening, there was a whole thing about the 2030 reduction, 2030 NDC numbers that China didn't want to have explicitly. So they didn't want to have it in the text. So then another country said, I think Germany said, we want to have 2035 numbers, but they were nowhere, or we only showed them in the plots, but the values were not there. So then there was kind of, the solution was that we remove it from the text, but we make a new table because that was acceptable for China. So on the fly, I had to make a table that was super high intensity. I mean, there was literally the moment that people were crying. It was about that moment. And
you kept the calm.
Yeah, and on the fly, I had to make that table, all the numbers. I had to make the table, and then it was half an hour later. I had to leave to get my night train. So I quickly made it. Had other people look at it because it was this kind of code, but still. And then literally in that half hour, it was gaveled. And when it's gaveled, it's accepted. It's done. You cannot change it. Otherwise, it's a whole process that you have to go through if there's a mistake. That was the most intense moment of my career. But then I was happy I had this package.
Okay.
That's the context. Yeah.
I know you're my hero.
That's the context of that. So. Hey, oh, sorry. Yeah, that's. Oh, yeah, that's.
I was trying to do this part and.
Yeah, for the temperature. Can you? I'm not sure if global mean is the correct name. Maybe, yeah, data variables. So if you look for temperature, there are different ones. Oh yeah, it is actually, but this is actually the better one. This one is for 1200 variables. The other one is the temperature that each model reports themselves, but each model has a different way of calculating temperature. For this, we did a harmonized calculation. For each of them, we used the same magic model, magic version, and we used, so you can use then this 50th percentile variable. Let's see if that works. Yeah. Yes.
But there is an error in importing data.
Yes, yeah. Oh, it's so can you, where did you put your data? Yeah, an AR6 files. Okay, so it's one folder up and then AR6 files. So I would actually do it in a relative way, because it's good. But if you go there, see if you have the dot slash, that's one folder up. Now this is an absolute value. So can I try something? Yeah, that's okay. If I would remove this and just say it's one folder up. So with dot dot, that means you go one folder up compared to where this is saved, and then you one folder up, and then the folder AR6 files, and maybe this works. Well, it doesn't. Let's go back. AR6.
Export these files.
Oh, it's not even one folder up. It's actually in the same. This is your notebook, right? So it's within the same folder in the folder AR6 files.
Oh.
It's good. It's so then we can we don't have to go one folder up. Delete. Oh, sorry. Delete. So just in the folder AR6 files. Still doesn't work. Why not? I'm sure this works. AR6 files. In the downloads.
In the downloads.
But this is a different. No, workshop. Oh no, this is good. Workshop. For the AR6 file. Oops. And this name. Can we try to put those files in the same one directory up? Can you try to do it?
One directory, these two files.
Yeah, these two files, yeah.
Copy these and here. no?
Yeah, yeah, no, there, yeah. And now I'm sure that this should work. But if it doesn't, then there's something else that's going on. This we can just do. This is this folder. Let's see. Yeah, now it works. I don't know why it didn't work before. But now it's just thinking, and it will. Oh yeah, the dot slash means this folder, and dot dot means one folder up. One dot means my current folder.
Where did it copy? How did you directly copied from selecting the data from the file in the first example?
Yeah,
Like you have given the name here
yeah.
directly from the file, from the CSV open.
Yeah, so what I do there is you need to find the variable name that is the output of the IAM. And this was about emissions. And so now we just open, yeah, I wouldn't open this one. This one is, you can do that, you can open in Excel, but then it's a very, very large file. So I already made like a selection of all the unique variable names. If you do the data variables, if you open that one, and here there's a list of all the variables you can choose from with the number of scenarios behind it. So now you can copy any variable here. For example, emissions, CO2 is probably in there.
Copy from here.
Yeah, yeah. And all these names, they are variables that are in the database. So if you're interested in one, you just copy one. So for example, emissions OC, and I don't even know what OC means. It's some kind of gas. You know it? Organic carbon? I don't know.
Because it is a folio.
Oh, and folio is organic carbon? Yeah, I'm not.
Agriculture, I think.
Yeah, that's afforestation. Yeah, so it probably has something to do with it. But let's just try this one. So let's copy this one.
Single cell.
Yeah. Yeah, there's one variable that we're interested in, and you put it there, and then you run this. And now you have all the values in just the first 5 rows, and then you can plot it there. But this is going well, so good job.
I think now that's the part, right?
Oh.
So feel free to go to the room
And have lunch.
and have lunch, and then of course we have the free afternoon. So feel happy to work on the group work report. If you like to all go out, enjoy the weather. There seems no rain in the end.
Perfect swimming temperature.
Yes,
I saw in the app.
Yeah, I mean, if you have questions for any of the faculty or ask on the project, feel free to reach out. Yeah. Is the recording stop?
Stop the recording. Stop it. We can